Today, we are going to learn some unknown and mysterious facts about ducks, so let's get started without further delay. Ducks can see ultraviolet light, helping them detect subtle cues invisible to the human eye. Some species are thought to use Earth's magnetic field as an internal compass during migration. Their social structures are complex, with behaviors and hierarchies that scientists are still deciphering. Certain ducks perform underwater courtship displays that remain rarely observed and shrouded in mystery. Many ducks are known to sleep with one eye open, a survival trait that still fascinates researchers. Some species can fly at speeds exceeding 55 miles per hour, leaving observers in awe of their power. Their migratory journeys can span thousands of miles along routes that seem almost cryptically determined. Ducks are extremely sensitive to environmental changes, acting as natural indicators of ecosystem health. The classic quack of a duck is far more varied across species than most people realize. Their calls and vocalizations include hidden nuances, some of which remain unexplained by modern science. In flight, many ducks form V-shaped formations that shift in ways that seem almost choreographed by nature. A specialized gland near their tail produces oil that waterproofs feathers, an adaptation with mysterious evolutionary origins. The intricate coloration patterns in many duck species hint at ancient evolutionary influences that scientists continue to study. Some ducks appear to navigate by the stars, using celestial cues in a way that remains partly enigmatic. Certain duck calls extend into frequencies beyond human hearing, suggesting secret channels of communication. Ducks may use ambient sounds to detect approaching predators, a survival tactic still under investigation. When threatened, a few species exhibit sudden, unpredictable flight patterns that puzzle both prey and predators. Their digestive systems can subtly alter water chemistry, a phenomenon observed only in passing by researchers. Migration routes in some species are not fixed. They shift mysteriously over generations. Recent genetic studies have uncovered ancient lineages in modern ducks that hint at lost evolutionary histories. Beyond sound, ducks use nuanced body language for communication that remains a subject of ongoing research. During breeding season, some species display unexpected color changes that scientists are still working to explain. Diving ducks can explore underwater realms in a manner that seems almost secretive and ritualistic. Certain ducks are known to dive over 10 meters deep, a capability that continues to intrigue biologists. The origins of domestic ducks are partly mysterious, with debates still swirling around their wild ancestors. There is speculation that some ducks can sense weather changes through subtle vibrations in the air. Isolated wetlands sometimes see sudden declines in local duck populations, a phenomenon that remains largely unexplained. Migratory ducks appear to use energy conservation techniques in flight that challenge current aerodynamic models. Some studies suggest that the geometric precision of flying formations may help reduce energy expenditure in ways not yet fully understood. During migration, ducks undergo mysterious changes in body fat composition to optimize long-distance travel. A few species communicate with subtle head nods, an intricate behavior that hints at unspoken social codes. Their feather patterns often serve as near-perfect camouflage, a design so refined it borders on the mysterious. The seasonal molting process in ducks, while well known, still contains elements that defy complete scientific explanation. Nocturnal mating displays have been documented in some duck species, occurring away from human observation. Urban-adapted ducks exhibit unexpected behaviors and adaptations that blur the line between wild and city life. In certain flocks, unexpected shifts in social hierarchy occur, leaving researchers wondering about the underlying triggers. Duck eggs sometimes display unusual color variations that hint at genetic mysteries yet to be unraveled. The process by which ducklings imprint on their first caregiver is both rapid and enigmatic in its precision. In folklore, ducks are sometimes seen as omens, linking their behavior to mysterious local legends. Detailed acoustic studies have revealed that some duck calls include harmonic layers that defy simple classification. Flock flight sometimes seems almost telepathically coordinated, suggesting an internal communication system still under study. Their migration has been linked to ancient environmental cycles that echo mysteries of the natural world. Local legends in various cultures claim that ducks can sense impending natural disasters before they occur. Some species choose nesting sites in unusually hidden locations, a selection process that remains a puzzle. Ducks produce unique digestive enzymes that allow them to process a wide array of food items, an adaptation still partly mysterious. The balance between ducks and their parasites in aquatic ecosystems reveals complex ecological interactions not fully understood. Observations of playful behavior in wild ducks hint at cognitive abilities and social interactions that continue to surprise scientists. Underwater, ducks sometimes communicate in ways that go beyond simple quacks, a subject ripe for future research. Preening behaviors in certain species have been likened to ritualistic dances, hinting at deeper social functions. Even neighboring duck flocks can have their own secret language of calls and signals that vary subtly from one group to another. Evidence suggests that ducks might experience a form of REM sleep, opening the door to questions about whether they dream. The evolution of their diverse beak shapes appears influenced by ancient dietary habits, an evolutionary mystery still explored today. Some ducks display an uncanny stillness on water, an almost perfect balance between motion and calm that defies simple explanation. There are occasional reports of ducks appearing unexpectedly in regions where they were not previously seen, sparking local legends. Microscopic analyses reveal that the intricate patterns on some ducks' wings are almost too perfect, as if designed by hidden natural laws. Migratory routes often align with ancient waterway networks, suggesting a connection to historical geographies. Ducks might be capable of sensing subtle vibrations through their webbed feet, providing cues about water conditions. Shifts in group dynamics during migration have been observed that hint at covert decision-making processes. Some species become notably more active on full moon nights, suggesting lunar influences on behavior. The rapid regeneration of duck feathers after molting is a phenomenon that continues to challenge our understanding of avian biology. In rare moments of calm, ducks have been observed aligning in near-perfect geometric formations while resting. A few species can rapidly adjust their body temperature, a secret adaptation that aids survival in fluctuating climates. Fossil discoveries of ancient ducks have spurred new theories about waterfowl evolution and lost species. Evidence suggests that some migratory paths may be passed down culturally among ducks, a form of animal tradition. There are instances where entire flocks vanish from one area only to reappear elsewhere, leaving ornithologists puzzled. The mechanics of energy conservation during long flights continue to reveal surprising biological efficiency. Some research hints that duck calls might incorporate elements similar to echolocation, though this remains speculative. Intricate mating rituals in ducks appear finely tuned to environmental factors, a coupling that has yet to be fully deciphered. In a few species, feather structures reflect light in unusual ways, creating displays that seem almost supernatural. Temporary alliances between different waterfowl species, including ducks, have been observed, suggesting a covert interspecies communication. Certain ducks display aggressive dive-bombing tactics toward intruders, a behavior whose triggers remain under investigation. The navigational methods used by young ducks on their first migration are remarkably precise, raising questions about instinct versus learning. Some ducks seem to detect minute changes in atmospheric pressure, influencing split-second flight decisions. Their buoyancy in turbulent waters is aided by complex internal air sac systems that are not yet completely understood. Variations in the subtle tonal quality of a duck's call might convey information about health or genetic quality. Observations indicate that some duck behaviors change with the phases of the moon, hinting at a lunar biological clock.